is a video on ratios and unit rates. A ratio is comparing two quantities by division. So let's see what that means. As an example, let's say we have a class of 30 students, 18 girls and 12 boys. Now, in saying what a ratio is, it's really important to listen or watch if you're reading as to what they're asked you to compare. So I'm going to compare the number of girls in the class to the number of students, total students. So girls to students, all students, is going to equal 18 girls to 30 students. Now, that's a ratio, 18 to 30. There's actually three ways we can write that. One is as a fraction like that. Other way is to go 18 colon 30. That's a colon there. And the other way is to just go 18 to TO 30. Now, ratios we usually reduce to simplest form. So if we have 18 over 30, we can go ahead and reduce that by dividing top and bottom by 6, and we get 3 over 5. So we can say that the ratio of girls to boys is 3 to 5. Let's look at the ratio of girls to boys. Girls to boys, we would say 18 to 12. We're going to simplify that, and we get 18, GCF is 6, so we divide top and bottom by 6, and we get 3 over 2. So the ratio of girls to boys is 3 over 2. The ratio of boys to girls is 12 divided by 18, which can be reduced to 2/3, dividing top and bottom by 6. So that's the concept of a ratio. I'm now going to get a new screen here, and so bear with me 1 minute here and get a new one. I won't save that. And for this new one, we're going to look at unit rates. So a unit rate is something that compares two different units, and with a unit rate, the denominator is 1. So what we do, a rate itself might be if somebody's going, for example, a unit rate would be 60 miles per hour. We might be given something, a rate of somebody, let's say they travel 180 miles in, let's say, 3 hours. Okay, so that's a rate. If we wanted to look at their unit rate, or at least their average unit rate, we would divide top and bottom by 3, because we want the bottom to be a unit 1. So we get 60 miles per hour. Okay, this is used a lot in, for example, grocery shopping. So if I buy, let's say, 100 for unit prices, it's always the dollars, the amount of money over the quantity, whatever it is. So, for example, if I buy liquid soap for $1.50, and I get 15 ounces for that $1.50, then what I get is, if I reduce that, I get point one dollars. That's a point, believe me. Dollars per ounce. Okay. Let's try another one. If I get a 12-pack of Diet Coke, to use a real life example for me, for $3.60. Well, what I'm going to do is take the $3.60, divide it by 12, and I get 36 divided by 12, or 3.60 divided by 12. It's going to be $0.3, or basically 30 cents. Again, that's a point there. $0.3 per, and this is 12 cans, by the way. $0.3 per can. Okay, I could put it per ounce and so forth and figure out that, but it makes more sense to have it per can here. So that's the basic idea of what a unit rate is, and a unit price. For unit prices, you always have the dollars on top. Now, I'm going to get a new screen here, and we're going to do a couple more things. I want to do a couple more examples because I don't want just unit prices. Let's say we're typing on a computer, and we want to know how many words per minute we're typing. Well, if we type for 5 minutes, and let's say in that 5 minutes we get 150 words, and notice what we want is words per minute, so the words go on top. We get 150 words divided by 5 minutes. That's a rate there, but we're going to reduce it. We're going to change it to a unit rate. So this one on the bottom is equal to 1. So if we reduce that, we get 30 words per minute. Okay. Now we're going to do something where we're going to use these things with dimensional analysis for conversion factors. And this is something you're introduced to in middle school, but this is something that you'll use in high school in physics classes, in chemistry classes, and in college in science classes, and in math classes. So it's very important. So let's say I have something like, and we'll use customary units here, but let's say, I'll do a complicated one at first here. So let's say we have somebody going 60 miles, I'm going to draw a big line there, miles per hour. I don't want it in miles per hour. For some reason, somebody wants it in feet per second. Well, what I'm going to do is keep multiplying by 1 in a special way until I get feet per second. And here's how I'm going to do it. First of all, I can multiply anything I want to by 1 without changing it, right? So what I'm going to do is multiply by 1 here, but I want to get the miles to feet. So I'm going to put a fact that has miles and feet in it. I'm going to have the miles down at the bottom. So the fact I know is that there, in 1 mile, there are 5,280 feet. Okay? Look at what this is going to do. I'm going to change pen color here for just a second. I can cross out mile and mile, and now I have feet per hour. Okay? So I'm going to continue. And so I have feet per hour. I don't want that, but I'm coming closer. I want feet per second. I don't know a math fact right off with feet and seconds and hours. I know a minute and hour one. I want to get rid of the hours, so I'm going to put 1 hour on top, and in 1 hour there's 60 minutes. Okay, if I do that, look at what this does again. I'll pick a different color totally here. Got hour here and hour here. Now I have feet per minute. That's not bad. So I'm going to go back. I'm just about there. Hey, I know a fact with minutes and seconds, and that is in 1 minute there are 60 seconds. Okay, and then I can go and okay, great. Now minutes cancel. And now all I have to do is multiply 60 times 5,280 and divide it by 60 and divide it by 60. I'm going to make some of that a little easier here, though, because look at what I have already. This happens to be 60 here, and this happens to be 60 here, so 1 and a 1. Here's a 0 here. I can get rid of that 0 and that 0. And then I have 528 divided by 6. I could reduce that a little further, but I think I could just do that by hand without getting the calculator out. And so I'm going to do this divided by 6, so that's going to equal 528 divided by 6. Well, that goes in there. 8 times 6 is 48. And that gives me 4 and an 8. This is going to come out really nice. And I get another 8. And so I now know that 60 miles per hour is equal to 88 feet per second. Okay, that's a complicated one. Let me do one more simple one. So I'm going to go over here and I'm going to get a new thing and don't save. And so let's say I have, here's one, 3.5, this is from your book, quarts per minute. And they want that in gallons. I'll put this way over, well, they want it in blank gallons per hour. Okay? So how many gallons, well, let's see, I'm going to erase my equal sign here because I don't want that yet. So we need to know some facts here, and hopefully you know these because you've had them in prior years. We know that there's 4 quarts in 1 gallon. Quarts goes down below because I want to cancel it. So I go here, cancel the quarts. And then I know that, and I want gallons per hour. Well, I know in 60 minutes, there's 1 hour. And so that's good. And so I can go here and minutes cancel. And then what I'm left with is gallons per hour, which is exactly what I want. So now what I have to do is 3.5 times 60 divided by 4. I could actually go here. This goes in here once, goes in here 15. And so whatever 3.5 times 15 is, and apparently that is equal to 52.5 gallons per hour. This again is very useful as you approach high school and college and science classes. So with that, I'm going to go ahead and end the video.